me. I mean, I can go for a walk if I want to.
Yeah, I can go for a walk as well. I can't go and do a test or an experiment. Now, did you see that?
Okay.
I'll see. I'll get it up there. Can you see the live stream?
Hang on. No.
Well, you can't see live stream text. Yeah, you
Oh
can.
yeah, I
You
mean,
posted it
yeah.
in there.
I'm in live stream text. Yeah.
Okay. Well, check this out. Oh, why is it not? Oh, I have to delete. There you go. Inspired by
If
you, so I can thank you for this.
all right, if B is raised, then the water level will raise in A and C due to the volume of water equalizing to a new.
And
Well,
we could also said that you could add water to B and extract water from B to
yeah.
have a similar effect on each end, right?
Hmm. Yeah, because if you raise B, then the water levels on A and C will rise. But would the water level in B not fall as well, so that it all stays level?
Yeah, that's the whole point.
Yeah. So
So
raising B
is the
releases the water level in
yeah
B,
turns
and A
into
and
the
C should
independent
rise.
variable, right?
Yeah. And A and C are your dependent variables, and it'll stay level even though they aren't horizontal.
They are horizontal though. That's the other two levels that will
Yeah,
be in there.
A and C are horizontal, but B won't be.
You think that'll be higher, but that's what a water level does. It establishes a horizontal plane. So how can you have a horizontal plane between A and C and have not B be part of that horizontal plane? That doesn't make any sense, does it?
It makes perfect sense though, because it's going to be level even though it's not horizontal. It's not a horizontal plane, but the water will still stay level in all of them.
You know, the
So
water
if
test
you
goes to show that it is horizontal. You can't have a horizontal plane between A and C and not have B be on that horizontal plane, can you? I mean, that does, seriously
yeah,
doesn't make
yeah,
sense, does it?
yeah, yeah, definitely. If you lift B, there's not a horizontal plane anymore. That's fine. But the water will still stay level. And
Well,
that's what the test will show.
that it equalizes. Look,
It equalizes, yeah.
yeah,
It
the
still stays level,
A
even
and
though
C
it's
due
not,
to the
there's no.
volume of water equalizing to a new horizontal plane. That's what it does, right?
What is the horizontal plane between now? Because you've raised B. So which ones are on a horizontal plane?
Well,
It's only A and C, right?
it will equalize, won't it? No, B is on that horizontal plane. That's the whole point of this test, right? You
But you
do
have
understand
lifted
the water level
you
test,
have
don't you?
you have yes, I do. They stay level, but you have lifted B. B is higher off the ground than A and C.
This is only
If
the
you take a
beginning one, right?
measuring stick, if you
The
take a measuring
measuring
stick
stick. Yeah.
and you measure from where the water level marks off on
On the
B to
canal.
the ground.
On the canal, it'll be. We're doing this at the side of the canal, so then the canal can be used as a reference frame for
Okay,
checking the heights of all of them. Right.
if you take it from the mark off point where the water is on B to the surface of the canal, that will be higher than C and A,
What
right?
B is
Because
going to
you've
be
lifted
higher.
B. Yeah, you're lifting B
That's what
up
you
a few
imagine.
inches. Your arrows under the thing
Yeah.
on under the level, under the part that you hold on B
Yep.
Do those not signify B being raised up, right?
Yeah, that's the independent variable, is lifting that
B
middle one, and then the
up.
water levels. Yeah, just lift it up like 2 inches, right?
Yeah.
Then the
So
water
if I
level
lift it
will
up 2 inches,
equalize on the
yeah,
other side, right?
they will equalize on the other sides, and
On
they will
A and
still
C.
be level with B.
Yes,
Yes.
yes, on a horizontal plane. Yeah, brilliant.
Yes.
You get it.
Yes. Okay. Cool.
So you're happy with that experiment now, then, right?
Yeah. So they'll be level on a horizontal plane, but they are at different altitudes. So Earth, so water can be level on an uneven on a curvy on an uneven surface. It doesn't need to be flat for the water to be level on a horizontal plane.
No, it's the surface of the water, isn't it?
Yeah, the surface of the water.
Yeah, it doesn't matter what is underneath it. The surface is a
Yeah,
horizontal plane.
the surface will be a horizontal plane, even if what it's on is curved.
Yeah, yeah.
So even on a ball, you can have a horizontal plane
On a ball.
of
Mhm.
yeah, that is level. The
How
surface of
how
water
would
will
it
stay
be
level on a
contained?
ball by its weight. Its own weight will contain it.
On a ball. It's like
Yes.
you can put a ball in a fish tank. Would that you consider that water
No,
on a ball?
no, it's not the same.
Well, because water needs to be contained, doesn't it? Because it's
Yeah,
only the
so the
surface.
water's weight will contain itself, but the ratio of water to ball is not enough when you it's not the right balance when you have a ball in a fish tank.
Yeah. Do you want to
You
give
need a
us
very
your
big ball
definition of
and
horizontal?
say what?
Do you want to give us your definition of horizontal?
Why does it matter? I mean, we've already agreed on what this test can prove.
The surface of water is a horizontal plane, is what I think we've just sort of.
It's what we've totally agreed. The surface, yes.
Yeah. Well,
But the surface can be horizontal even if the water is resting on a ball. That is what this test also proves.
you already just established earlier that no matter what the shape the underneath is, the
Yeah,
surface would be
well,
horizontal.
horizontal.
Yeah.
Exactly. So the shape underneath can be that of a ball, but the surface will stay a horizontal level plane. You can have a level surface on a sphere.
A horizontal surface. How do you work that? Because you understand what horizontal is, right?
Yeah, it's a horizontal plane. So
It's straight, right? And the plane
at
is,
each point,
yeah.
you could draw a tangent on the surface of the sphere. This tangent would be horizontal and it would be perpendicular to plumb, which is vertical, at that point.
Right.
But if you had tangents at different points, those tangents would not be perpendicular. Sorry, they would not be parallel to each other. Yeah, exactly that. At a specific point. That doesn't have that. It wouldn't be that all through. Exactly,
Yeah.
perfect.
A horizontal
So
line
that
goes
one,
like
that
that.
yeah.
Mm.
So that vertical
Mm.
would be your tangent
To be
touching a
perpendicular.
specific point.
All the
That vertical,
verticals on that horizontal line would be perpendicular to it, right?
all the verticals on that horizontal line, yes.
Yeah.
But on a sphere, all the verticals would not be parallel,
But we're
and
not
that's how
talking
it
about the
is on
sphere though.
Earth.
We're talking about the horizontal surface that the water established, right? That horizontal plane, that one that you just said about that the water has, right?
At a specific point, yes.
Yeah, with perpendiculars, the verticals are perpendicular to a horizontal, right?
At a specific point, yes.
Which specific point?
Wherever it is that you drop your vertical.
Like this. See that?
Yeah. At that exact point where your plumb is touching your level, at that specific point, they're perpendicular.
Interesting.
Yep.
What about if you was to add more?
What do you mean add more?
Well, like
Add
if
more points?
another plumb, Bob, or something.
Another plumb? It wouldn't be parallel to that plumb. If I drop a plumb and you drop a plumb, our plumbs are not parallel.
You leave my plums alone. Yeah, check that then. That's 3 plums going through a horizontal plane established by the water level, right?
Mm-hmm.
So which one of them is perpendicular and which other 2 aren't? Does it depend which one you drop first?
No. Well, just looking at it, they would look perpendicular, but I'm sure if I had instrumentation that was sensitive enough,
Yeah.
I could see that they're not all that they're not parallel to each other.
But you would agree that vertical and horizontal are perpendicular, though?
Yes, at a point.
Well,
Or yeah,
I mean,
even
they-
on a
they
straight
are,
line,
or
yes.
they are not, right? Yeah,
They are.
Mm.
They are.
right. And
At a
see
point,
the stuff there.
and on a straight line, I guess, yeah.
Definition 10. It's even wrote on the thing.
Mm-hmm.
That explains what a perpendicular is, right? The definition. It's definition 10 in the Elements Book 1. If you want to have a look at it.
In a straight line, standing on another straight line makes adjacent. Yeah. So when the lines meet,
Two
where
straight
they
lines.
meet, where an angle is created at the point where the lines meet.
Yeah, 2
If
straight
that
lines
angle
though.
is 90 degrees, then they're perpendicular at that point. Yes, across the whole lines, but at that point where
But
they're perpendicular.
you understand that you need 2 straight lines.
Yes, and when they meet at a point, they become perpendicular.
Okay. So then if you move along that line and drop another perpendicular, then it's going to be perpendicular and they will be parallel, right?
Oh yeah,
Yeah. Right. So then
Yeah.
plumb bobs that are dropping are perpendicular to the water level, the horizontal plane, and therefore they are parallel, right? Geometrically.
but the water level isn't a straight line.
Of course it is. You can see the water level on the left and the water level on the right. The horizontal plane is established all the way in between that. That's what a water level does, right?
If you had a water level in your hand and I had one in my hand,
Can you
and
see it there? It's on that picture.
I see it there. I totally
Okay.
see it there, and I totally agree with your picture. I'm just giving you a different scenario that would give us the same results. If you had one of the tubes in your hand and I had one of the tubes in my hand, and we had the plastic tubing in between was long enough, and we could hold the tubes in each other's hands, and we could turn our phones on and show each other the tubes and measure.
Yep.
The
They would be
level
the same
reading.
level, right?
They would be the same level, yeah.
Sweet. How far is that tube? Could you get that tube to be, do you reckon? How long?
It would have to be
Infinite?
over 2,000 miles.
Yeah,
It would
infinitely
have to
long.
be pretty long, yeah, to
But
get
you-
from you to me.
You are having the fact that tube and the water level within that tube would establish a horizontal plane over an indefinite length then.
It would travel over a curved surface, but still stay level.
A horizontal
I'm saying.
plane. Because that's what
I'm
a
saying it
water
would-
level does, right?
I'm saying it would
establishes a
travel
horizontal
over.
plane.
It establishes a horizontal plane over a curved surface by using a datum as a reference. That's what I'm saying. How do you know you have your horizontal? You
like you
drop your
said
plumb
before,
line at a
the
point.
water level doesn't matter on what the shape of the underneath is. It always establishes a horizontal plane, right?
It always establishes a horizontal plane,
Right.
yeah. But
Okay.
but what I'm saying is underneath it's a sphere.
Right. Okay. But I mean, you do understand what a horizontal is, right?
I do.
Right. And
But
that
but
horizontal can
underneath the
be
surface.
established over what 2,000 miles. You said.
No, that's not what I said. I
You did. You
said
said the
we
water level.
I never said that.
You did.
Yeah, I said the water levels will show a level reading for you and for me over a curved surface. Because you can have level over curvature. You can also have level over, a flat ground.
I'm just
It
making
doesn't
a
matter.
brew in the kitchen, so you can go on and explain. I won't be a second.
Oh, take your time, man.
Right. So you've got a water level that establishes a horizontal plane of reference. And you know my test is to show that it establishes a horizontal plane of reference. So as far as you're concerned, is it worth me actually doing this test, or should we tell people that the water level just establishes a horizontal plane of reference no matter what the shape is underneath?
You might as well. But the secondary purpose of the test is that the water level will establish a horizontal plane of reference between A, B, and C, even though A, B, and C are at different altitudes. They are at different heights
What are you talking
from
about?
the Earth's surface.
Where
So
where'd you measure that
you can
altitude from?
hang on, let me finish. Because you're measuring from the ground all the way up to the water level reading. Remember, you've lifted B higher off of the ground than A and C. So even if the shape of the floor is not flat, you can still have a level reading.
Yeah, that's what a water level does. I think you get
Yeah.
it. You know your
Yes. No, no, I
your
fully
thing
get it.
is
So basically,
sea
what
level,
this test
right?
proves
Yeah, yeah.
is that it doesn't matter what the shape of the surface is underneath, you will get a horizontal level reading. So to say that water always finds its level or water looks flat proves that the earth is flat is wrong.
Well, see, I don't think that's what we just did. We're doing about the water level being horizontal, right?
It's exactly what we just did. We
So
just nullified the claim
if I make a
that
statement that says
that water
that level is a straight line on a horizontal plane, would you agree with that? Because I mean, you did just say that
No, I
water.
wouldn't agree with that.
You did say that water level establishes a horizontal plane, didn't you?
Yes, water level. A water level?
Establishes a
No,
horizontal plane of
I would say
reference.
leveling is just determining the height of one level relative to another. You want to level out the heights of two different levels at two different points.
Yeah.
Yeah.
So like the canal, when they take, you keep going on about altitude, right? So we'll just get it sorted that it's referenced from sea level, right?
Mm-hmm.
Right. So when they were building the canal, they
Mm-hmm.
they came from sea level and they raised up like it's 51 feet in 3 locks. Can be measured. So you have the sea level, and then each lock will be divided by 3. You know, these are only small locks. They're not big locks like you guys imagine with your canals. So 51 feet, what's that? Just 17 feet each lock or something.
Okay.
So it comes up that, and then it at Liverpool end, it's 51 feet ish. Right? And then you go all the way to the other end, 27 miles further away, and that is also 51 feet because it's the same level.
Yeah. But now, all three. So let's say you have your levels, and
Mhm.
all three of them are 10 feet off of the ground. All right. You've put them.
Why?
You've connected them.
Why would you want to
Hang
give
on.
them?
Hang on.
Just put them at
You've
the side of the canal, a few inches off the floor on the side of the towpath. At the side of the
Okay.
canal.
Cool. At the side of the canal, 2 inches off of the floor. All three of them.
Well, you'd
And
have to.
and
Yeah. Go on.
say what?
You wouldn't really be able to put it 2 inches, would you?
All right. 10 inches off the floor.
Yeah.
All right. Cool. All three of them.
Mhm.
Then we take B and we lift it an extra 2 inches off the floor.
Yeah.
So B's 12 inches off the floor. The others are 10 inches off the floor.
Yep.
There will still be a level reading and a horizontal plane of reference. All right?
Well, the water level will equalise, won't it? When, as
It
soon
will
as you lift
equalize.
that middle one, it will equalise.
It'll equalize.
Yeah.
It'll equalize. But it's equalized even though they aren't at the same altitude. They aren't at the same elevation. There is not flatness between them.
Yeah, that's what it does. The water level establishes a horizontal plane of reference. That's
Exactly. It establishes a horizontal plane of reference regardless of the shape underneath it.
yeah.
So this proves that just because water looks flat, it doesn't mean the earth is flat.
No, it just means that it's horizontal on the
Plane of
the
reference.
water is.
The water surface is horizontal. Yeah,
Yeah.
it's equalized. But what's underneath it, what it's resting on, could be a ball, it could be a triangle, it could be whatever. It doesn't mean it's flat though.
Well, at the edges of the water, you need like an edge, don't you? Like to be a container. You know, like a lake.
No, you
Or like,
don't.
let's start small. A puddle. It has edges, and it's a puddle because it's a divot in the thing, and that's where the water lies, right? But the water surface would be horizontal plane, wouldn't it? Right. So you go a little bit bigger. Let's say a swimming pool. Right. Well, that has a container of the edges, but the water level in between is horizontal plane of reference. So let's go a little bit bigger. Let's do a canal. Right. It's like a big trough, isn't it? It's just contained though. So it's just the water level is a horizontal plane of reference in between. Go a bit bigger. Let's have a lake. Well, the lake has edges at the side of it, doesn't it? And that's the container for the lake. It's like just a big puddle, like a big divot that's filled up with water. Right? Go a bit bigger. Let's say an ocean. It has sort of land at each end of it. It's sort of so that's just like a big lake, isn't it?
Mm-hmm. Yeah, big, super big puddle.
Yeah, but
But what's underneath
the
it
horizontal,
is still curved.
but the surface of the water is still a horizontal plane of reference, isn't it?
Regardless of the shape of whatever it's resting on,
Yeah.
it'll stay a horizontal plane, which proves that just because it's a horizontal plane on the surface doesn't mean that what's underneath it is flat. So it nullifies that flat Earth claim.
Yeah,
That's exactly what this experiment proves.
Yeah, nobody's been here to prove anything about anything shape of anything underneath. I mean, I'm just here to get you to realise that level
I
means
already realized that.
horizontal. Yeah, did you not
I
know that?
already I knew that long ago, Bev, but that wasn't the point of the experiment for me. That wasn't the reason I wanted you to try the experiment.
Oh, you right? Okay. Well, no, it was your idea to turn it into an experiment.
Yes,
Like it was just a test before.
it was definitely my idea to turn it into an experiment.
Yeah.
And the purpose of the experiment was to show that regardless of whatever the shape of the object is that the water is resting on, the surface will be level. That was
Yeah.
the purpose of
Yeah.
the test. And this thus not nullifies the flat earth claim that because water looks flat at rest, it must be resting on something that's flat. There's no curvature. But that nullifies this claim.
Well, I don't know what you claim you're making is the shape of whatever's underneath.
Yeah,
water.
because it's a flat earth argument. I mean, that's or what? Are you not doing this for the flat earth?
I'm not doing it for the flat Earth. Well,
Okay.
have
If
you
you're not
seen-
doing it
have you
for
seen the
for the
mountains and
flat earth,
valleys?
all right. If you're not doing it for the flat earth, then there's no need to do the experiment because we both agree then already that water will equalize and form a horizontal plane of reference
Sweet. And who are you?
and always be
who are you
level at
speaking
the
for then?
surface. I was speaking for
Are you,
myself.
are you doing this for the globe model?
No, I was doing this for myself. I thought you were speaking for the flat. I was mistaken, and I apologize.
So who are you speaking for? No one. You're
I
just
was
speaking
I was
for
speaking
you.
for myself.
Yeah, sweet. Well, that's all I'm doing is speaking for me. But we
Okay.
both can agree that the water level is horizontal, right?
We both agree that water level creates a horizontal plane of reference.
Sweet. And like we both agree that a horizontal is perpendicular to vertical and
At a
having to
point,
be
yes.
a straight line, right? Horizontal is a straight line.
Yeah. So when two straight lines meet at 90 degrees, at that point,
Yeah.
they are perpendicular.
Yeah. And then you can
On
just
a-
travel further along the horizontal and do another perpendicular, can't you?
I could. It's the same way on a curved surface. I could take a point, draw a tangent, and then drop a horizontal that
horizontal
is perpendicular
Isn't a curved
to the
surface, though, is
tangent.
it?
Hang on, though. Hang on. It's the same way on a curved surface at a point. I can draw a tangent, drop a plumb
Horizontal
at
isn't
that point.
anything like
Come on,
a
man.
curved
Bev,
surface.
you gotta let me finish, man.
You can't say it's the same
Come on,
because
man.
it's not. A
But let
straight
me
line
finish.
isn't
But you're not letting
a
me
curve
finish.
because you're talking
You're
rubbish.
not letting me finish. But
Yeah,
you
but
don't even know what I'm trying to say.
You're just
'cause
trying to
not
say,
letting me
okay, go on then. Go on.
Okay. Okay. So it's the same way. On a curved surface, I can take a point, draw a tangent, drop a plumb line that's perpendicular to the tangent at that point. On that same tangent, which is now my horizontal, I can go drop another plumb, and it'll be perpendicular to my initial plumb.
What?
That was at that point on the curved surface.
No, you can't.
Yes, I can.
No, yeah, you best
'Cause
get some
you-
geometry lessons because you're conflating a tangent.
Should I?
With a
No,
plumb line.
the tangent is my horizontal.
Sorry, you can't have
No.
a.
Yeah, the tangent is my horizontal. Exactly, the
No,
tangent
yeah.
is my horizontal.
No.
On that tangent, I have dropped a plumb
Yeah,
that is perpendicular to it.
yeah.
And if I now move along my tangent, along my horizontal,
Yeah.
and I drop another vertical, it'll be parallel to my first vertical that I had dropped on the tangent drawn at that point
In reality,
on a curved surface.
Not on a curved surface. No. That horizontal needs to be perpendicular. So, yeah, I think you've just made a little bit of a boob.
I don't think you're visualizing what
No.
I'm
Well,
saying.
you try draw it, right? Do you do a drawing for us and show us what you mean?
Okay. It's going to be a very
Yeah, really rough. Make it really, really rough. But like you understand that a horizontal is a very definite position, like as is a vertical. Right? I think we established last time that you've never done any surveying. Have you ever actually done any practical work at all? Building type stuff?
no, I did not study engineering. No,
No, I mean
I
like
studied theoretical physics.
have you ever put a
No,
shelf up
I
or
don't.
anything like
I
that? No.
Oh no, yeah, shelf I've done.
Yeah.
I've built a shelf for
So you
myself.
know you have used a level at least.
I didn't need a level to build a shelf.
You didn't need a level.
No, it was these little IKEA things, dude.
Oh,
You just
that's a unit. That's not a shelf. Like a shelf is something you put up on the wall, and you need a level to make sure it's level.
something like where I had to drill holes into the wall and shit. No,
No. So you've never actually used a level.
I've never needed to use.
Have you
a
ever?
level, no.
Have you ever put a
I've
picture
put-
up on a
I've-
wall
I've
and then
played
just
around
looked
before.
at it and gone, "That's not quite right," and messed about with
Yeah.
it until it looks right? You're
Yeah,
trying to
I
make
have.
it look level, right?
Yep,
Right. So it's a very definite position, isn't it?
yep. Ooh, try to get this line straight as possible.
I'm not going to mark you on all of that. But make sure it's like, if you just label it as a straight line, I can imagine what a straight line looks like. And like, remember as well, like a horizontal line is explained by the words a horizontal line. It gives you position, direction, everything. To say a curve, you would need to give us some definition for it, like I don't know, some sort of like a radius, distance would be good. The best way to describe a curve.
Okay.
How come you're the only brave one to come and chat, mate? What's up with everybody else?
I don't know. You gotta ask them. I don't want to speak for other people.
Do you chat to the surveyors or anything?
To surveyors?
Yeah,
No,
yeah.
I don't know surveyors in real life.
You not know Jesse Kozlowski? You not chat to him?
Nope.
Okay. Who do you hang about with then? Who's your crew?
No one. I don't have a crew. I just come on here for the fun of it. I'm not really that invested in the whole debate. I think it's a bit silly.
Okay.
Yeah.
You think
I,
the conversation about levels a bit silly, or it's a bit silly to think that you can have a horizontal plane of reference over like 2,000 miles, but imagine the shape underneath it is a ball.
I think the conversation that the Earth is flat is a bit silly.
But I'm guessing that means it's easy for you to imagine a water level establishing a horizontal plane of reference, but then that being able to sit on a ball, right?
I think that's very possible, and I think that is what's happening.
That's sweet. Even after we went through the puddle, lake, canal sort of container
Yeah,
sort of thing.
yeah, that's still possible on a ball because it's the weight of the water that holds itself to whatever it's on,
And
and the
still
surface will
establish
always be level.
a
It will
horizontal.
still, it will still establish it.
Still establish a horizontal plane of reference.
It would still establish it. Yep. That's exactly what the test we just performed,
We
or
just
you would have performed. Well, we didn't
we
perform it, but the one that we went through just now, you were drawing at the start.
yeah.
That's exactly what that proved.
It's a horizontal plane of reference, right?
Established over an uneven surface that is not flat.
Well, it doesn't matter what what the
Exactly. It
undulations.
doesn't matter what the surface is. So the surface could be a ball. It would still work.
Not
Yep.
so sure
You
that.
you've just agreed with me. It doesn't matter what the surface is. Those were your words. So the surface could therefore
No,
be
the
a ball.
surface.
It
No, no,
doesn't
no.
matter.
The surface of the water is a horizontal plane of reference.
All right. What about
It
what the
doesn't
water's
matter
resting
what
on?
it's sitting on, does it?
What it's sitting on?
Doesn't
Okay.
matter what the
Cool.
shape of
You
that
can
is.
okay. So the shape of what it's sitting on could be a ball. It would still form a
Well,
horizontal plane
but
of
it
reference at the
needs
surface of the
edges,
water.
doesn't it, to contain the water?
Yeah, it can
Like
have
like
edges.
like a
And those
lake.
edges can conform in a ball.
But
It doesn't matter.
how does a horizontal plane of reference wrap around a ball? How does that work? You
By
realise if you have a
having its own
horizontal,
weight.
right? By having a horizontal, you establish a vertical perpendicular to that horizontal plane of reference, right?
At the surface of the water, yes.
Which the surface we've just agreed is a horizontal plane of reference, right?
The surface of the water, yes, regardless of what the water is sitting on.
And
Yeah.
that horizontal surface of the water would establish the perpendicular to it, which you would call verticals, right?
Yep. Regardless of what the shape of the thing is that the water is sitting on.
Yeah, well, I think that's established anyway. I mean, that's not like a great
Yeah.
thing to work out.
Yeah, yeah, it's not that controversial. It doesn't matter what the water's sitting on. It's not that big a deal.
It doesn't matter
It
the
could be a
shape
ball.
of. It doesn't matter
It
the
doesn't
shape
matter.
of the container, right?
It
That's what
doesn't
you mean
matter
by
the
what
shape
the
of the
water's sitting on. Is it
No,
doesn't
I
matter
never
the
said
shape.
container. You said container. Maybe that's what you mean. All I mean is the shape of the object the water is sitting on does not affect whether or not the surface of the water stays level. That's all I'm saying.
Yeah, but levels
If you
horizontal,
want to
right?
talk about if you want to talk about containment and things, that's on you.
Well,
I say the weight of the water contains itself. That's me.
well, horizontally, right?
No,
You admit that it
on
has to have
onto a
edges.
sphere.
What?
I never admitted it has to have edges. You're the ones talking about edges and
No,
containment. I'm
the
telling
canal.
you that the water contains itself using its own weight. That is the force that keeps water on Earth. Yep.
Wow. You can really hold both of those beliefs at the same time.
Yeah. They're not, it is not a dichotomy. They're not mutually exclusive. They coexist. They function well together. And reality matches up with that. It is not a contradiction at all.
Fascinating.
The object the water is sitting on does not matter. You have said that yourself.
Yeah, it doesn't. The shape of the container matters not a jot to the surface of the water establishing a horizontal plane of reference.
Okay, all of a sudden you've started adding the word container. It's not what you were saying before. But if you want to call it a container, that's fine.
Do you not think? Let me see. I
I
did
can't
one
argue. I
initially.
can't
Did a
argue with
question
the fact
ages
that
ago.
water always has boundaries of land on it, around it, whether it's land in the form of dirt or land in the form of ice, the way we have it at the Antarctic.
Well, I don't know about that. Have you ever been there?
But
Have you been there?
no, I've
Are
seen
you,
pictures of it.
are
The
you,
same way
are you suggesting
I've
that
seen pictures of it.
ice can contain water?
I'm suggesting that ice can act as a barrier around liquid water. Yeah,
You
like an
realise
ice
that
wall.
whoa, you yeah, you realise ice sits on top of the water, right?
Yeah, true.
Right. So
It floats on
how
top of
can
it. Yeah.
floats? So how can something that floats on top of it be a container for it? What are you talking about?
Hmm.
You're not suggesting
Good
surely
point.
that
But if
would
the
work.
ice is dense enough, it could act as a barrier.
If it was
It could get in the
dense
way.
enough, what
Yeah,
does that mean?
means density.
Well, it means you could get denser water in the form of ice that contains water. I'm not so sure. I think you should rethink this ice wall thing. I would say go
Yeah,
back to the landmass containing, like, because
yeah.
that seems more sensible, doesn't it? That
You're
like a
actually right.
like a
You're
bit.
right. Yeah,
So
you're
far
right.
we've
You're
got
right. You're right. So yeah, the ice sheets wouldn't act as a container. You're right. They would just tend to float then. So it would only be like land, like dirt land, that would act as a barrier then.
yeah.
Okay. Yeah. I give you that one.
You,
Calling it a container though, I don't know. That's on you. What I say acts as a container is the force of the water's weight keeping itself on the Earth's surface.
right. Well,
That's what I say. Acts as a container.
could you say if I was to like stomp and make a bit of a hole and fill it up with water, make a little puddle, then would you say
Mm.
that the bit of land around the outside that's sort of a bit higher than where the divot is the container for that bit of water?
No.
Would you not?
No.
Okay. Well, what
I
about
would
like when
say
they dug the canal, right? They dug it and then they lined it with stone and clay and all of that. Would you say that is the container for the water within the canal?
no.
No. What about like
No.
a lake and the shore of the lake being a higher than the level of the water? Would you say that becomes the container for the lake?
No.
It's like the topography of the land becomes the container for the water
The
within the lake.
topography causes a barrier to how the water flows. It causes it to concentrate at one point. That point being the point where the water's weight is strongest, where the
Weight,
force of its own weight is strongest. Yes,
a
because water has
force,
weight. Yes, because water has weight as well.
a weight force.
Yes, the weight force.
The weight force. Did you just make
The
that
weight
up, or did
force.
I help you just make that up then?
No, I mean there's a different name for it. I don't want to invoke that name because it's gonna start a whole different argument. But I think we all agree that water has weight.
Morning, spot on.
And
Yeah, morning.
yo, what's up, dude?
Yeah, all right, mate.
Yeah, but I think we all agree water has weight,
What are you
and
doing to your
water's
mic
weight.
there? Whoa, Nate, back off the
Oh,
mic.
sorry. Can you hear me now?
No, you've gone a bit too far away. You're sleeping.
how
You
about
put
now?
it. Did you? It sounded like you put it right in your mouth.
Yeah, it was right
Also,
on the
there's one thing to add here. When you're talking about holes in the ground that get filled with, well, that fill with water, not get filled with, that fill with water through some form of natural water feed. So water coming from a higher elevation, settling. If you had a lake, for instance, and the water would flow from a higher point. If it had been raining, the water would flow into the lake, and then the lake would settle at a certain level and would find its balance with the land around it, because the land around it would have to be saturated completely to the level of the lake. Otherwise, the water in the lake would just permeate into the land. So, apart from when there's clay lined situation, which could be a barrier completely to contain the water, then yeah, the water will rise and fall in the lake depending on the amount of rainfall that either fills it or the amount of sun that evaporates or it drains away. Yeah,
Or geological conditions of the underlying bedrock or whatever, you know.
yeah.
Yeah, right, Nate?
Yeah, what he said, I totally agree with. There are a lot of factors you would need to take into consideration.
But
But if you had a lake that was lined the same as the canal, where no water could escape, at what point would the water not be horizontal or level? What distance would it have to be?
infinite.
The
Nate's
water
already
would,
said that. We have
the
done
water
that,
would,
haven't
it would always be level.
we? Yeah.
All right, cool.
Always.
I didn't hear that before.
Yeah. Yeah, 2,000
regardless
miles.
of regardless of the shape of the thing it's resting on, it would always be level. Bev and I agreed on that
Okay.
already.
So what happens if the canal's 27 miles and it's filled and no water can escape either end? That water would be level for 27 miles. That means that basically that level would be the same from one point to the other. And 27 miles is a lot of curvature.
Yeah, it would still stay level. It's a simple example is just your swimming pool at home, right? It has the deep end and the shallow end,
Yeah, he has a swimming pool. I
but
know.
it's but it stays level. Or your swimming pool at the local gym. It has a deep end
Yeah. But what I'm
that
saying
slopes
is
up
that
into the
canal,
shallow end, but it
that
stays
canal,
level at the surface.
but the canal over
Morning.
27 miles. I don't know, mate. The
It's
canal over
okay.
27 miles would have to be considerable. I mean, I think it's like probably like 120 meters difference from one end to the other based on sea level. That would have to, like, the land would have to, be exactly that height to contain that water.
No, Nate's already told us it's
Alright.
horizontal. It doesn't move, does it, Nate?
No, that's what I'm saying. Though.
Yeah.
I'm saying that the line horizontal from point A, 27 miles later, 120 meters, land should have dropped off 120 meters.
You're
But you've
reminding
leveled it.
Nate of.
But you've leveled it. Though.
That's the shape of the thing underneath, isn't it, Nate? Tell him.
Yeah, the shape of the thing underneath doesn't matter because you've leveled it.
Leveled what?
The surface.
Yeah, the surface
Yeah.
of the
Yeah, the
water
water's
is
done that,
horizontal.
hasn't
Yeah.
Yeah, the surface
but
of
then
the thing is
if you
horizontal
measured-
and level. It doesn't matter what you build on. It doesn't matter if you build on a ball. It'll stay level. You've leveled it. Just use your swimming pool. Use a swimming pool as an example. That is the simplest example.
So hold on. So the land.
You don't
let's
have to
just
go
say-
too far from there.
Yeah, okay. So let's just use this 27 mile, because this is real. Yeah, it's the same as a swimming pool. The canal's real when it's 27 miles long. So the land at one end is, like, I don't know, are you in inches or millimeters? But I don't know. So 6 inches one end from the surface to the path, and then the other end is 6 inches to the path, or 150 millimeters. Then really, those 2 points would be level, yeah, both the water and the path.
I don't understand what you just said.
Okay. Yeah. So no, what I'm saying is
That
if
was
the
poor.
yeah,
You
that's
didn't
right, mate.
explain it properly.
I'll try to do it
Say it
again.
again.
I'm probably
Yeah.
not the best at explaining.
No, you're
but
doing brilliant there. You're just dealing with cognitive dissonance here, right? Big time.
Duh.
yeah, but you
You
got
didn't
20.
explain it
So
properly.
what I'm saying is the water from, so let's just say point A to point B. Now you're saying that the water's level, yeah. So if you go to
The water's
Liverpool,
level at its surface.
yeah.
That's okay. Cool. Yeah. Mhm,
Yeah.
That's what
So
I'm saying.
if you measure with your tape measure to the path that you stood on in say Liverpool, and that's 150 millimeters, 6 inches, and you're on the path, yeah.
But what do you mean when you say that? I'm
Well, I'm just
measuring
yeah.
from the water level reading to the floor to the ground I'm standing on, or
Yep.
okay,
So
because
that's
the water level is suspended, let's say on a pole, 10 inches off of the floor, right? Something like that.
yeah. You just measure with your tape measure down the side of the bank to the path, and it's 6 inches from the path to the water. Then you go 27 miles along the water and measure the same the other end, and you're stood the same distance from the water the other end, yeah. You're still 150 millimeters from the water.
150 from
Six
from it
inches.
in a horizontal direction or vertical.
Well, the what?
I don't
Have
understand.
you know? Say if you've got a tape measure, yeah,
Mm-hmm.
and you're stood next to the water, and you put the tape measure down the side of the canal and measure, and it's just literally 150 like 15 centimeters. Sorry, yeah. Did I say 150 centimeters? 15 centimeters, which is 6 inches, yeah. Then you walk 27 miles to the other end of the canal, and then you do the same. You measure down from your feet on the path to the water, and that is 100. That is 15 centimeters, 6 inches too. So those 2 points on the land, depending on what happens between those 2 points, doesn't matter. But those 2 points are level with each other according to the water.
Yeah. Have a look in the chat there. We've got the old channel tunnel things.
Oh yeah, that's a good one. Yeah.
That's a good one to explain. You'd agree with that, Nate? The topography is the container.
No, the weight of the water is a container.
How can the weight of the water be the
But-
container?
Are you? Because that's the force that keeps the water down on the Earth's surface.
No, but that's not the container, is it? The
It is.
container is what is contained in. That is what's being contained. What is being contained cannot be its own container.
The water just conforms to
To a
forces of-
container.
to the forces that act upon it.
No, it remains within its container until it's released from that container. If it's
Well,
a canal, the
By
lock,
forces, yeah.
the lock,
Oh.
no,
Hold on, DP,
Yeah.
because we were discussing a minute ago.
Yeah,
that
yeah.
There are a few more. No, you're right, mate. But I'm just saying that we were just speaking. I was trying to not explain, but I was just going through it in my own head, and I think we all agreed that actually, if that's permeable, what's beneath, then that water will get higher and lower. Not necessarily in the sea, because the sea is filled. It is so, the land below it is so saturated that all the water can do is sit above the bed of the sea. Yeah. And any
Mhm.
water coming in from the river will like make it rise, and any evaporation will take it away, and then it will be fed again by whatever source. Yeah. But
Mhm.
so it does act. The two ends do act as a container of sorts, but I don't know. Actually, no, I'm thinking about it. That maybe that isn't a container, because
Thank you.
it's-
The
sea
two ends
level-
don't matter.
No. I'm just saying that sea level, or in unless it's a sealed unit, then the water has to either penetrates down or can penetrate left or right, yeah, into the land. Because I know somewhere where there's it gets flooded every year, and that water is based upon the river level or nothing on the land can go until the river takes the water away or it gets saturated another way.
Like that there,
Exactly.
like contour lines.
I totally agree with you, dude.
Yeah.
The topography of the land is dictated
yeah.
by the path of the water, I guess.
Yeah. So I don't know if the land is actually containing anything, as in.
Exactly.
So it is
The
literally
land,
going up and down.
the land is just there, man. The water will conform to whatever forces act upon it, regardless
Honestly-
of the shape of the quote unquote container.
I'm
It
just
really
speaking on
doesn't
behalf
matter.
of myself here as well. I'm not speaking on behalf of anyone else. I'm just talking.
Yeah.
No, I same with me, and I think you and I are on the same path here.
But the surface
But
of the
there is a
water
difference.
is horizontal, right? We
The
all
surface-
agree that the surface
We all
of the
agree on
water
that.
is a
That the
horizontal.
surface of the water is horizontal,
Hey,
regardless
hey, Flex,
of the
remember.
quote unquote container it is
Welcome
within.
to the flat Earth, then, mate.
Yeah, you, exactly.
Oh, no,
you,
no,
s-
I'm
you,
not a
s-
flat
you
earther,
said
dude.
the
No.
container
No, nor am I,
it is
mate.
in.
I said quote unquote because you guys want to call
The
it a
container,
container,
it is in. The water
quote
is what is
unquote,
being
because that's
contained.
what you guys want to call it.
Hold on,
I'm not
Let's
calling
not
it a
talk over each
container.
other.
Yeah.
Hey, let's not talk over. Come on, let DP have a go, then
Oh,
you can
sorry,
respond then, Effendi.
All right, no problem. Sorry,
No,
man. Go
no,
ahead.
I'm just going to
Well, no, just I
reiterate.
can't hear anything.
I'll just reiterate what I said before, that the water is what is being contained, and what is being contained cannot be its own container. It's just doesn't work in English.
No, but why does it have to be contained or in a container?
Well, the water, if you take a canal as an example,
No, a canal's different.
Well, a lake then.
yeah, a lake, you've got the banks of the lake contain the water.
That
Whether it's a
water seeps
natural...
into the bank, mate.
Sorry?
The water seeps into the edges of the bank, and that water will go under that land to the level of that lake.
Yeah, but
So
it is
it's not
still
contained.
being contained enough to form a lake.
Yeah.
Hmm.
The
I'm struggling
the
with
amount
it.
of water being added to the lake is more than the amount of water seeping away from the lake. Like you made that example of your river that floods every year. Yeah,
Mm.
the reason it floods the land is because the river bursts the bank. It breaks the containers. The containment of that river is the course of the river.
Yeah, but hold on, mate. Hold on. The only reason that that water's being contained is literally because it's created. The water's following the easiest path.
Yeah, the path of
Exactly.
least
The easiest
resistance.
path. Yeah.
Yeah, the path of least resistance,
Which is
and the banks
its own weight.
and the banks of the river are what contain that river. Once the river reaches the tops of the bank, it bursts the bank and therefore bursts its containment, flooding the land around it.
But it fills up that bank bottom up, right? Because it doesn't want to
how
resist
else,
its weight.
how else would it do it?
Yeah, and that's the path of least resistance.
But
By
it
just
still,
going
it still,
along with its
it still
weight.
breaks its containment. The river bursts its banks. It breaks
But
the
its
containment
but its
of that
containment
river.
isn't what holds it there. It's its weight. Regardless of its container, it would still be held there.
I wouldn't agree with its weight. It's purely down to the fact that the land has taken what's the word like. So the land can only take in so much water, yeah. So therefore, and depending on the land as well, because it's
Geology and topography.
Yeah.
I mean, there are some rivers that run across clay, and the clay doesn't soak up any water. The water will not absorb into clay subsoil.
Yeah, it's like the bit where we live.
Yeah,
Great for building houses because they use the clay for making the bricks.
yeah.
But
And also
the
the
water
canals.
is terrible. Yeah.
Canals are
But the
lined with
water's
clay.
weight, but the water's weight is still a factor. The
No,
water
I
still has
dis-
weight in that
I
situation.
disagree. I disagree. All that's happening is the water is denser than the air, and therefore it sits on the lowest point
Yeah.
due to its density, which happens to be the ground. It's,
But see, if you were to if you had like a gravel section of land that was a mile long, and you like rake and dug a ditch all the way down that mile, the water would just run straight through the quickest path through the gap. Yeah. But if you so when you fill that up, eventually, if you filled that trench up and just did it till it was full and then left it, that would then drain into everything else, and then depending on how deep the trench was, would level out. Yeah. So it's a difference between flow, finding the easiest path, and seeking its own level.
Yeah, very big difference between those two.
well, and because when the water's flowing,
It's not at rest.
It's not at rest, yeah, and it will
Yeah.
only seek its own level when it's at rest.
Yeah.
Yeah, so when all that water falls down and comes down and goes in the canal that's 27 miles long and stays level, then point A and point B, one end and the other, would be horizontal with itself and level.
Mm-hmm. Yeah, we know that.
No, I was just wondering what Registered thought about that. I think he agreed earlier, so you must.
Yeah, I totally agree. I totally agree with everything.
Wait,
The
what
So-
Earth
you're
isn't
saying?
flat though, and this doesn't prove that the Earth is flat.
All right, so we got another. The longest bit of canal in the UK that has no locks on it is 41 miles long.
Mm-hmm.
So
Oh. Yeah, I've calculated on that. I haven't used it for a long time.
Nate, have you ever used the calculator? Which calculator do you use?
What do you mean, like a scientific calculator?
no, Earth curve calculator.
You imagine a curve, right? For the
But they
shape
never use the calculator.
underneath the horizontal water level, right? You imagine a shape. Do you have an imagined size shape?
So sorry, can DP? What's the distance of that now?
41 miles.
41.
Yeah.
Nate,
Right. So let's just.
Yes.
you imagine you live on a shape that has a horizontal water level at the top of it, right? That shape, any idea how much curvature that shape has? You imagine? Or we already know you imagine that the water level's horizontal, but the actual shape bit, how much curve do you reckon there is in that shape?
On average, because it's not a smooth sphere, so on average, I would say there is 8 inches of curvature per mile squared. On average, it's not that everywhere. It's just on average.
That's nice. So,
I've just
over
put a picture
41
in,
miles, how much do you reckon that'd be? If you're working that maths, have you ever done it? So 8 inches per mile squared. You'd have to get 41 miles and square that first. Right? Do you know what 41 squared is?
Not off the top of my head.
Have you got a calculator on your phone? Do you want to try it?
You do it, man.
You do some
Like I'm-
maths.
like
Come
I'm-
on.
like-
Come
like
on,
I'm tired,
Nate.
man.
Yeah. Come on, let's see
Why
you do
don't
some
wanna
maths.
do it?
I've never seen any Globe believers do actual maths or anything like
I've never
that.
seen Globe.
I've-
I've never
I've
seen
never
Globe
seen-
believers do anything.
I've never seen flat earthers do math.
Well, we're trying to
It's a
help you out
horizontal
here.
plane of reference.
doing
We've
so.
already established that, haven't we? So we're just talking about the shape underneath the horizontal plane of reference.
I'll give you a clue, Nate. The first number is 1,
Okay.
and there's 4 numbers that you're looking for. 41 times 41 equals 1.
It's a big number, isn't it?
Yeah, it's quite a big number, Bev.
Are you doing it Are you doing it in your head, Nate, or?
I'm not doing it at all, man.
Oh,
I mean, you
well,
guys
you're
can
not
do it
even
if you want.
trying it.
Not even trying.
I don't care.
You could do
What do you mean you do-
40 times. Let's pretend it's 40 then, make it easy, because that one might be a bit difficult. 40 times
I don't
40, can you
even
do
know.
that?
I don't
In
even
your
know
head.
what you guys want to do, man.
Like, is it like 4 times 4, and then you add some zeros on after it? Would that work? Something like
Dave,
that?
do you know off the top of your head how many feet in a mile?
Ooh. No. Couldn't.
Alright, let's have a...
1,500 meters. So, can be about 4,500. Isn't it?
Nate,
is it?
do you know how many feet are in a mile? You're American, aren't you? You deal with that a lot more, don't you?
Yeah, it's like 5,000, 5,200 feet in a mile.
Fisher, why do the Americans pronounce it like that? 5,200.
That's a point as well. You know,
5,280.
in America, do you have a feet and tenths of feet? You know, like, do you
What
have
do you mean?
fractions of feet? Do you?
Fractions of feet, yeah.
Y-
There's fractions of feet, inches. I'm 6 feet, 2.5 inch. That's how tall I am.
2.5
example.
inch.
Yeah.
Right. So, have you ever heard of like a measurement saying 5.37 feet? Would that be like a number that you would easily be able to work out?
Yeah.
5.37 feet. Who said that?
You get 5.7 feet.
There you go. See, look, he says that you do. In America, you do.
That's mixing imperial with metric.
Yeah, they do that in America. Did you not know?
What?
Tell him, Nate.
Really?
Yeah.
Like, are you saying like 5 feet 7 inches, or?
No,
No.
5.7 feet.
No, it's not the same.
No, no. We don't. I mean, what's smaller than feet?
Inches.
Well, we have
Um,
inches, but I don't think they do in America. Let me see.
Yeah, I would say I'm 5 foot 7.
And
That's 5 feet 7 inches.
Yeah,
Right.
that's
That's
what
not
you do. But
5.7,
you're
is
not
it?
a surveyor, are you?
It's not 5.7 feet, though, is it?
Yeah,
I'm 5'7".
He doesn't
How
know
would you
about the surveyors.
interpret if someone said they're 5'7"?
5'7" is 5'7". That's not 5.7 feet.
Oh yeah, it's not 5.7 feet. No, it's 5 feet 7 inches.
Yeah.
Yeah, there's 12 inches to a foot. So
Yeah.
it's not metric where it's a point after every 10, right? Or 100
Right.
or whatever.
So-
Yeah, no.
So if somebody was, say 5'8" inches, would you say they're 5 3/4 foot?
The thicknesses of the black lines and the white space.
Yes.
So at the bottom.
But you wouldn't say they're 5.75 feet tall.
No.
No.
And then
Wait. Yes.
have this hash mark
Wait.
going
Yeah,
up.
well,
0.75.
yeah, because 0.75 is 3/4.
Yeah, but you're mixing imperial with metric, so which you can't do.
Oh, no way. Right, I've just put this link. I've stopped it at a time to save it, and it's 3 minutes 33 into it. It should be starting at. But this is the main surveyor going over all of the things in America, right? And this is how they do surveying in America. And I look at the measuring rod he's using and listen to the words he's.
Oh, he was
says.
using tenths, wasn't he?
Of feet.
Tenths of a foot. Yeah.
It's nice, isn't it? Like, well, Nate, any comment on that?
Any comment on what, man?
Them using
Using
tenths of feet.
Tenths.
Mm-hmm.
Mm.
Yeah, a tenth of a foot would be what? About a half inch?
Well, you tell
That'd
us.
be a 24th, wouldn't it?
No, a tenth of a foot is generally a half inch.
Yeah, a half inch would be a 24th of a foot. Just
No,
off the top of my head.
no.
No.
Well, how many inches in a foot, Nate?
Well, don't
12
be-
inches.
Wow.
12 inches in a foot.
Okay, so you got 12. You got 1 foot divided in 12.
Yeah,
so
so how many-
how many half inches in a foot?
In an inch.
Oh, yeah.
Start off easy.
Yeah. Okay. Yeah. How many half inches in an inch?
Gets challenging, this basic maths.
The
doesn't it?
maths. Yeah. You still there, Nate?
Yeah, I'm here.
Yeah. How many half inches in an inch?
How many half inches in an inch?
Yeah.
Yeah.
I don't know how many half inches are in an inch off the top of my head. No. All I know is that the tenth of a foot is generally half an inch.
You don't know how many half inches are in an inch.
I would
Do you
say
know-
two. I don't know.
You would say.
Do you
I
know?
would say two. Obviously, half inches in an inch. I just feel it's a silly question, So
Well,
that's what
yeah,
I'm laughing about.
Can I just?
But there are
sort of
2 half
put
inches
mate?
in an inch.
Right, can
Like
I-
half inches.
You know.
It tells
Okay,
you.
Do you know
that
what
it's
a
two. Come
12th
on,
of a
man.
foot is?
Like you can't ask me how many half
Nate,
inches.
do you know
are
what
in
a
an inch.
12th of a foot is?
And you said you don't do maths. So
Come
We have
on,
to-
man. These
Nate,
questions
come on.
are silly.
Yeah, I know, but this is going to come to a head pretty easy, right? A 12th of a foot. Do you know what that is?
Yes,
What is it, Nate?
it would be 1 inch.
Right. So a tenth of a foot is what?
A tenth of a foot is half an inch.
how can that even follow, Nate? How can that?
Fantastic, Nate. Absolutely fantastic. Your logic
It is.
works
it is
even
about
down
half
to the
an inch.
mathematical level. You sweet.
No, 1/24 of an inch of a foot is half an inch. If you've got 12 inches in 1 foot, there must be 24 half inches in 1 foot. There must
Okay.
be.
There must be.
So 1/10 of a foot is how much?
It's whatever you say it is, man, guys. I don't know what the point of all this questioning is. I feel like we've gone very much off topic, and I
Well,
don't
I
understand
was-
why
I was trying- I
we're
was
doing
trying to-
this.
we
It's
were
like 4 in
actually-
the morning, man.
We were actually trying to get you to realise how much drop there would be in the longest unlocked stretch of canal in the
So
UK.
how much drop would there be? Tell me.
Well, you won't do the maps, Nate. You're lazy and you won't do the maps.
Okay, let me get an Earth curve calculator out.
Can I just
And
point
we-
out again
and we
that
do
this
this.
drop is only in the shape underneath, because we've, as stated before, the water level is horizontal, right? So this is
Yeah.
the drop of the shape underneath your
Underneath.
yeah.
Over 41 miles.
Yes.
Okay.
Are you waiting for us to do it, or are you actually having a go now?
He said he was getting a calculator.
Right. Yeah, I'm trying to find a calculator.
Have you got a mobile phone or a PC?
Yeah, but my phone is like a bit far away from me, man. Like I'm too lazy to go and get my phone.
Oh man, such an effort.
Yeah.
Can you not do it in your head? Like, just pretend it's 40 miles, and then you can always add another one on afterwards, can't you?
Yeah, because one squared isn't. It's not rocket science maths, is it? Is spot one still here?
Yeah. I'll make
Yeah,
it
mate.
through again.
Yeah, I'm thinking of making it.
Okay, so I think over 40 miles I would get 1,000 feet drop.
Try again.
Yeah, you didn't sound confident there when you said that. You
No.
was like, really?
Yeah, it was
Yeah,
rough
that's
again.
that's just a rough calculation.
Do you think it's a
I-
bit
but I-
much
but I-
or not enough? Like, what were you quizzing about that?
Yeah, 1,000-foot drop over 40 miles. I mean, that's a straight line, man. If you saw
try
that
again.
line on your horizon, that line would be straight. You wouldn't
Try
even
it.
be able to tell.
Try again. Your maths is wrong. Try
Is
again.
my math wrong?
Yes.
This is over how many miles? 40 miles? All right, let me pull out a calculator.
I think it's 41 miles.
Over 41 miles?
I think that's what you said.
Oh,
Yeah.
I thought you said over 40. Okay.
You got your formula working right. You said 8 inches per mile.
Okay, so it
squared,
says, yeah, over 41 miles, it says 1,121 feet. So 1,121 feet. Over 41 miles.
Is that geometric?
What do you mean?
Is that like it?
Yeah.
Yeah, just a geometric shape.
Mm-hmm.
You know, I'm still trying to make you grow. You know, some people would be upset with you doing that because you realise they say that's a parabola. You understand that?
What's I just used the first calculator I found, man.
Oh, you like, was it Mick West's Metabunk one?
No.
No.
No,
Which
this is
which
not a Metapunk.
this is somebody else's Earth curve calculator. Can it be trusted? Or did you just do it with your numbers?
That's the one I used. And I wasn't far off with my own calculation. So I calculated 1,000 feet. This one calculated 1,121. So I was off by 121 feet. Not too bad. For 4 a.m. in the morning. Like, come on, guys.
Yeah.
Don't make me do this, man. I'm not trying to do math.
At least you did it.
Yeah. It's more than most ballers do.
Yeah. But yeah, 1,000 feet compared to 40 miles is a straight line. 1,000 feet drop over a 40-mile stretch. That is nothing. Since there are 5,000 feet in a mile. That's literally nothing, man.
What?
It's not even a mile drop.
Dude, it's 1,000 feet.
1,000 feet is not even half a mile.
Yeah, so why doesn't the water spill out the edge?
Does the water
Because of its
does the
weight.
water go down?
Because of its weight. Its
that
weight
drop.
keeps it on the Earth's surface. Its weight is the force that holds it down. A force is needed to keep it there. If you guys want to say it's more dense than the air, that's fine.
But no, Nate.
But is
Nate.
density your force now?
That means the canal, right, at one end could be nothing. Because it's got a horizontal plane of reference, the actual water, right? What you've just said is that at the other end of it, it is 1,000 feet deep. The canal
No.
trench.
that's
Yeah,
not
yeah,
what I
because
said.
the horizontal water level in the top. So you've just told us the drop of the shape that's underneath the water surface. Do you think that's how far they had to dig down to make that canal at the other end of it? Or actually, which end did they start digging it from?
Yeah.
They best
That
just
was
make it
middle.
1,000
Down in the
feet
middle.
deep all the way along, eh? Just to make sure that they start at different places.
Start in the
That
middle and
drop-
do 500
that-
feet.
That
each end.
drop is over a curve.
That
So
that
from my end, I would say the other side of the canal is 1,000 feet below me. But if I went to the other side of the canal, I would say that my original position is also 1,000 feet below me because it's over a curve. It's over a hump.
Yeah, guys, I've got to go to the toilet. Expose his cognitive dissonance to him, will you please?
If you are at two sides of a curve relative to each other, we could both be above or below each other. You would be 1,000 feet below me. I would be 1,000 feet below you because we are at two opposite sides of a curve.
how can that even
Of a
make
hump.
sense in your head?
Easily.
If I'm standing 41 miles away from you along a canal, you're 41 miles below me, or you're 1,000 feet below me, and I'm 1,000 feet below you.
Mhm.
How does that
So-
even make sense in your head?
All right. If you go to just look in the live stream text chat, if you look at that image that Stop the Drivel posted, that screenshot from, I think that's a curve calculator, right? So you have HO and H1, right?
Mm-hmm.
So let's say at HO, at that point where that blue arrow touches the surface of that curve, we drew a tangent and we dropped a vertical on that tangent, right? So from that tangent, using that as our horizontal, H1 would be below us. But if I went to H1
no.
and
We're
I
not
drew
talking.
a tangent,
We're not talking about standing on the tangent, though, are we? We're talking about standing on the green line. And you are talking about
Mhm.
standing on that green line 41 miles away from me, and I am lower than you, and you are lower than me. Whereas if you look at that diagram that you are referring to, H1 and H2, where they meet the green line, are, guess what? Near enough horizontal. They are near enough on the same plane.
where what do you mean? Where HO is on that green line and where H1 is on the green line
Yeah.
are not horizontal. They are horizontal when you level them on that checkered line, right?
Yeah, but we're not talking about standing on a tangent from each point, are we?
No,
We're talking
okay.
about standing on the ground.
All right, let's say we're standing on the ground on that green
Right,
point.
okay, right.
On
So
that green line.
hang on,
All right.
hang on a minute, hang on a moment. All right.
Mm.
So if we dig, you are saying that the surface of the water is level, is horizontal.
At that checkered line, yes.
Right.
That was the focus, yeah.
Right. So say HO and H1 are 41 miles apart. They are the distance that we are looking for.
Mhm.
Okay. To dig a channel from HO to H1, okay, they have had to go through 1,160 feet at point X, where your horizon is arrowed.
Okay.
They have had to
So-
dig down
Yeah.
1,160 feet. This is further than the Shard is tall. And the Shard is the tallest building in London.
Okay.
They've had to dig down.
When you say dig down, you mean all right. So let me just try and visualize this to make sure I'm seeing what you're seeing.
It's not difficult, really.
You drew a straight line from the point where HO is on that green line to H1. So it went through all that gray stuff. And you're saying at that arrow in the middle where it says horizon, if you went down from there and it hit the straight line between
Mhm.
H1 and HO, that
Mhm.
would be how deep?
1,100. This is your calculation.
Okay.
Your 1,160. Well, I can't remember what it was off the top of my head. 1,160 something feet. This is the calculation that you made.
Yeah.
Bev was saying that it has to be 1,160 feet deeper at one end or the other, which, yeah, it could be. But, and this is according to your ball model. This is the stuff that you have to believe for your ball to be true.
No,
And
I don't think
you don't
I
even
don't think it
realise.
works like that.
You don't even realise that you have to believe it. You've agreed that the level of the surface level of water is horizontal. You've got
Mhm.
no choice.
It's horizontal, yeah.
It has to be horizontal. It can't be horizontal.
Regardless of what it's sitting on, yeah. It'll
Right.
always be horizontal.
So regardless
On
of what
Earth.
it's sitting on, you are saying it has to be horizontal. So
Mhm.
therefore you have to have a level between HO and H1.
Yeah, you level it out.
Yeah. In which case you have to dig down 1,160 feet at horizon point.
What? You keep changing that last part because what you're saying now, horizon point, you weren't saying that earlier.
The horizon point on the illustration that we are looking at
Okay,
in the live stream text, which is the optimum point of the curve of your ball between those 2 points, between H1 and HO. That point, from where it says horizon with the arrow pointing down to the green line where the tangent meets the surface of the curve, that point down to your level water point has got to be 1,160 feet. The amount of curve between the 2 points.
Yes.
Yes, you agree.
I don't like the way you're phrasing it, but yes, I agree.
Yeah, you agree.
Yeah,
So,
I genuinely get what you're saying. I I get what you're saying. Yes. At that point, that's how much that's how much drop of curvature or how much curvature there is. Yes. At where it says horizon, at that horizon point. Yeah.
so you seriously think that they dug down over 150, 180 years? Or no, longer ago than that. I think the 1700s maybe. I don't know. When the canal was built, you think they dug down over 1,000 feet? Oh, man. You back, Bev?
Yeah.
Yeah, he agrees that the amount of curve between the
Yeah. But he agrees that the water level's horizontal at the same time. It's fantastic,
Yeah,
isn't it?
Yeah.
he does.
Yeah. It's horizontal. Doesn't
And it's
mean they
level.
have they have the same horizontal level. Doesn't mean they have the same elevation. Doesn't matter what the surface shape or topography is of what they're sitting on. The water will stay level,
Yes.
and it'll be contained by its own weight.
Yeah. Yeah, it's fantastic how you think you can do that. I mean, you obviously don't put an awful lot of thought into how each of those thoughts can occur at the same time. Do you just
Oh,
concentrate
trust me,
on one
I
at a
do.
time?
No, they all blend into each other perfectly.
Blend.
If you guys don't agree with it, it's fine, man. Like, trust me, you're never gonna convince me otherwise. So you're wasting your time.
I don't have to convince you otherwise.
I don't have
The
to.
only
I'm
thing
not trying
was
to convince anybody
the
anything.
horizontal
All right.
water level. I mean, there seems to be the sticking point that everybody else has, but you seem fine with it.
Yeah.
And the tenths of a foot, tenths of an inch, whatever it was.
Tenth of a foot being smaller than twelfths of a foot. That's right, isn't it, Nate?
What?
I don't even understand what you guys were talking about there, man.
Well, you had a tenth of a foot
be
as
honest.
being half an inch, and a twelfth of a foot, as we all know, is an inch, because there's 12 inches in a foot.
Ooh.
Yeah,
Yeah, I see now.
it's like a tenth of a foot would be like 1.2 inches, wouldn't it?
Yeah.
Oh, don't confuse him with actual working.
Real maths.
Yeah, and actual things that are
Real
actually
math.
proven, visible, and actually work.
Well,
You've got
curious.
to presuppose
Curious.
everything, you know, without actually any proof.
Curious, we actually got a bowler doing some maths just now.
Yeah.
You missed it by about 10 minutes, I think.
And that was pretty accurate, wasn't it?
Well, after the second or
You
third
put some
attempt,
numbers
yeah.
into the calculator.
No, I was
yeah.
accurate,
Yeah.
man.
A
You know, yeah.
presupposition.
When I did the calculation on the calculator, I was off by like 126 feet compared to the calculation I did in my head.
Yeah, but it was only the
No,
it was only the square root of 41, wasn't
That
it?
wasn't a calculator, though, Nate.
No, I
You
did the
put
square root
some
of
numbers
40.
into a
I
thing
used
that
the
they
wrong
call a
number.
calculator.
Okay.
You didn't actually do the maths, did you, yourself?
I did it in my head first, and I got 1,000 feet. And then when I did it on the calculator, and when I did it in my head, I was using 40
What was
miles,
the sum?
and it turned out I was wrong. I
40
was supposed to use
squared
41
is
miles.
1,000. Is that what you got?
So,
When you did it in
No.
your head, you said you got 1,000 feet. So, what was the maths sum that you did? Something equals 1,000 feet. What was that little sum that you did in your head to get you 1,000?
it was the curve calculation, 8 inches per mile square.
Oh,
Using
right. So
40
40 squared times 8 is 1,000.
What?
Yeah? Or did you have 12,000 because you knew that inches, it was going to be inches, because it was 8 inch per mile squared. So the answer would be in inches, not feet. So you'd have to have an extra one of knowing how many inches there were in a foot. You must have done that mentally as well when you came up with your answer of 1,000 feet, right?
Yeah, mentally. I don't even know what you're saying, man. But yeah, that was my answer, which was wrong. But I was pretty close, man.
So you did 8
Well, I'll be honest
inches
with
per
you, if
mile
you
squared.
came out as a curve, you were completely wrong.
Yeah, I mean, I was off, man.
8 inches per mile squared in your head for 40 miles came out as 1,000 feet, right? And you thought that was good because it was pretty close to the number that you got to when you put some numbers into a calculator on the internet.
Yeah,
Yeah, and you were proud of that, right?
exactly. I was.
Yeah, nice.
I was, man.
DP was proud of you just for putting the numbers in the calculator on the internet. That right, DP?
Yeah.
Yeah, Nate's been agreeing with us all morning that the water level, the surface of the water, is horizontal.
Which means flat and non-curving.
Yep. Yep. Over like a infinitely long distance as well. That works, doesn't it,
Yeah,
Nate?
otherwise it wouldn't be horizontal.
Yeah, yeah. Yeah, Nate
It can be
agrees.
horizontal. It can be a horizontal plane that is level over a curve as well.
No, it can
We
only
agreed
be
that
a
it
horizontal
doesn't
plane.
matter what it's
can't be
resting
over
on.
curvature. It can only be a horizontal
It
plane
can
if it's
be.
horizontal.
Yeah.
You know,
Bev and
you
I agreed
unless-
that at the
unless you-
surface it can be horizontal regardless of what it's resting
you're
on.
using what's called double speak. Double speak. What
No,
double
no.
speak
No
actually does in
curiosity.
an argument
You're not
is
hearing him
destroy
right.
both positions that you're trying to attain. You know, you can't have double speak because doublespeak destroys not one argument, destroys both your positions, which means what you're talking is bollocks.
No, the surface of the water, he agrees, is horizontal. What he says is he knows the shape of whatever's underneath the water, right, Nate?
Yes, sir.
Yep. So you can have, in Nate's world, he can have a horizontal surface of water on a ball.
Yes, sir.
But this is what I've just said. You can't have that because that's doublespeak. And doublespeak
No, it's
destroys
not.
both your positions of any argument you bring forward, which
No,
means
it's
it's
not.
wrong. It's as simple as that, and that's the basic
It's
logic.
not.
That's how it works.
It's
not
not, but it's
doublespeak.
fine, man.
It's like saying you can have light dark. Do you believe you can have light in the dark, a dark light? Yeah? Is that what you believe? That's
No,
what you're
it's
saying,
not.
mate. That you
It's not what I
literally
believe, and
saying-
it's not what I'm
You're
saying.
literally saying you can have black light.
I'm not saying that at all.
You
But
are,
it's cool,
you
man.
actually-
You know,
no,
you guys don't
actually
need to
are.
agree with me. It
You
doesn't
are-
matter.
you
I don't
are-
care.
No, you're in such a poor state of religious belief that
Okay.
you're literally concocting things in your mind to make it work, rather than
All right.
accepting the actual facts of what things are.
It's cool, man. I'll carry on believing in my Ball Earth model, which, when used in the scientific method, always makes predictions that turn out to be accurate.
No, there's no
Well, you guys
scientific method-
believe
no scientific
in the
method
flat Earth
applies. There's no
that has no
scientific-
science.
There is-
I mean, there's
what
no
science-
science coming from the flat Earth. There's no technology coming from the
what-
flat Earth.
what
Nothing is being
science-
created
So
by the flat
now,
Earth.
so now, what's going to happen now? Even though I've only just come on and only just started to speak, you are now going to talk over me.
I'm
Is that
sorry.
your scientific method?
I've been here the whole evening, man. Like, I've
Yeah,
been here for a
well,
while.
I
It
haven't.
was
I've
just
only,
me and
as,
Bev.
as I've just said, if you'd actually listened to what I said, I have only just joined and only just started
Oh,
to
okay.
speak. And now as I'm here, saying something and challenging on things, now you're going to
I'm
speak
sorry.
over me, even though you've
I
had all night to
apologize.
speak.
I apologize.
See, all I've been doing today is feeding you breadcrumbs and allowing you to just waffle and say things. That's what they've been doing. They're allowing you to double speak. You're
All
talking
right.
about scientific methods and science. You haven't got any. You haven't used any. You've never proven R. Ask me. Just tell me now. How did you measure the distance to the horizon when, according to your side, everything's refracted and you can never see the horizon?
It's horizontal.
We only have one horizon.
Mate.
How did you measure it?
Nate has a horizontal water level. He's got no chance of measuring the shape underneath it. Right, Nate?
No, we can measure the shape of the Earth.
Underneath the horizontal
it's been
water
measured.
level that you've just agreed on all morning,
Yeah,
evening.
yeah,
call it
we
what
know,
you want.
we know what the shape of the Earth is,
Really? And how do you know that? How do you know that?
because human beings have measured and they told me.
No,
what
no,
it
no, no.
was.
no. Sure. What measurement, were, and when? And how did they measure it?
Well, I don't know how they measured it
Well,
using
do you know
that,
what, mate?
that
That's the very
geodesic
first.
equipment, but I can
No,
Google
no,
it.
no,
Let
you
me
don't-
Google
no,
it
this-
for us.
The very first thing you need to establish is how they measured it, because you need to check they did it accurately and correctly. Now,
Yeah, but I trust them. I trust that they.
yeah,
did it
you
accurately
blindly
and
trust
correctly.
them. Yeah, you do.
I do. I trust
So-
them. They have given me no reason to distrust them.
Did-
There's no reason
right,
I
so
shouldn't
if you
trust
see an horizon, if you see the,
geodetic surveyors. They've never
so
lied.
if you forget the village, you don't know geodetics says you don't know any of this stuff. So go back
I
to the very
don't, but
basics
they've
of what
never
you
lied
see.
to me.
You've just using a calculator to tell you how far away the horizon is from you. Yeah, the geometric horizon. Do you have a geometric horizon?
He doesn't know. It's horizontal.
There's a geometric horizon and an apparent horizon.
No, there's only one horizon.
No, well,
No,
we don't
can you
see
Show me, show
we
me
don't
right,
see the real horizon.
exact. Okay, so you don't see the geometric horizon. Now, can you tell me how you measure something you cannot see?
Because we've measured Earth's circumference.
No,
using
no.
Earth's circumference and radius
no,
using a
no.
segment. of its surface.
That's not true, is it?
We've also measured it using geodetic surveying.
No,
I don't know how it works.
no.
but
You're
I
just making
trust them.
assertions. You're making assertions.
Yeah, I'm making
assumptions.
assertions.
Now, tell me now.
Based on trust and belief. I don't see anything wrong with that.
Nobody has ever seen the geometric horizon.
Yeah, no
just
one has
said.
ever seen it. But it can still be measured.
It can't be.
Yeah,
If
you don't need
can't
to
see it,
to
you can't measure it.
Why? Says who? Bollocks. Bollocks, man.
You know, like you keep talking about.
I can't see
Whoa.
sound, but I measure
You
it.
keep saying
I
and
can't
talking
see
about
air,
geometry,
but I measure
right?
the weight of it.
So
It's
how did they
bollocks
measure
to
it?
say that I need to see something to measure.
How did they measure it?
Measure the weight of air? You use a
No,
barometer.
not air. It's a
I
completely
can't see
different
air,
thing.
but I measure
We're
it.
talking about the geometry of the Earth, the geometric horizon. How did they measure the geometric horizon? How did they come to the value that they used to calculate everything else?
I don't know, dude. I've already told you that. I don't
I
know.
want to know. I want to know how you managed to measure something that nobody's ever seen.
How do we measure air? No one's ever seen it, but we measure it.
You stop making false equivalencies. I
How is
want
it a
to
false
know about
equivalence?
geometric horizon. Don't shift from that particular point.
How is it a false equivalence? You're saying, you're insinuating it's impossible to measure something we can't see. And I'm telling you
We can
that's
use-
false.
Right, in Earth, we can use pressure gauges, yeah? We can put things into bottles. We know how much pressure. We know how
Yeah.
many molecules it's got. We know all those types of things. We know its weight to its amount of molecules. There's things like that. Yeah? We haven't got the geometric horizon. You've just admitted it.
No,
It
I've
doesn't
admitted we
exist.
cannot see it with our eyes. It exists, but we cannot see it.
It exists. But
Yeah, we can't see it. Air
we can't
exists,
measure
but we
it.
can't.
We can't.
We can't-
We can't weigh it.
can't
We
measure
can't
it. Just 'cause we
paste
can't
it out.
see it
We
doesn't
can't. We can't do any of the
We
other
can
things.
measure
We
it.
can do. We can't do.
We
any
can
of the-
measure things we cannot
Okay, so
see
you're gonna.
easily.
Okay, carry on talking over me.
Oh, come on. Geometry, right? Nate? How do you do geometry? What is it when you're talking about your geometry? What do you think of when you hear that word? You start drawing
what do you
shapes.
ask?
You start drawing shapes, right? Don't you? Isn't that what you think of?
No, when I think of geometry, I think of points, lines,
Right,
bases, and distances.
Okay. But you've already said that the water level is horizontal, right? So that's a
The
straight
water level
line.
forms a horizontal plane. Yeah.
Yes, that's a
It
straight.
levels things out.
It's a straight line, isn't it?
I wouldn't call it a straight line. I would just say it's
It's
level.
horizontal. You've just said it. A
it crosses
horizontal
a
is
horizontal-
horizontal is perpendicular to a vertical, and
point,
perpendiculars
yes.
have to be straight lines, right? In order to have a perpendicular, you need to have a straight line. So a horizontal line, therefore, provably, geometrically, straight line. Right, now if the water level that you establish is a horizontal plane, I mean, even a plane, that's a straight line again, isn't it? That's another just doubling down on straight lines. A horizontal plane contains all of the straight lines.
We're kind of going backwards, though, Ben. Don't
Yeah,
you
well,
think?
we just go into your geometry. You're looking for a geometric horizon, right? But you have already said the water level is horizontal. So there is your baseline is a straight line along the floor from your feet. That is the geometry of your starting point. You agree on it. You've been agreed on it all the time. So that's where you're starting from. Right? That is your reference. That horizontal plane is your reference for your starting geometry. And since geometry actually literally means earth measurement, if the only thing you have got is a straight line as your reference, all perpendiculars upon that will be parallel geometrically. You agreed on it. So what was the calculation you were doing earlier? Something about the shape underneath that straight line, right? Which we've already agreed doesn't matter what the shape of the container is. It needs a container.
It's a container.
Yeah, like I did a question on Twitter. It was early on last year. What is measured by volume but comes without a container? Try thinking. 2019. Have a think. We've got 3 of them. But they're answers that I'm not so sure you come up with, and I'm not going to give you them because that'll take the fun out of it.
Yeah, but you've also got the position where when he doesn't want to answer something, he'll be dumb about it.
Yeah, he just says,
know.
I don't know about that. But
Yeah,
I mean,
yeah, even though he does times, yeah, because it undermines his actual position.
Yeah.
I mean, that's just...
Well, I don't know much about geodesic surveying.
do you know anything
not a
about
surveyor.
geometry? Because that's all we were talking about just before.
I do. All I
Can-
said was geodetic surveying has been used to measure the size of the Earth. When asked how they do it, I told you I don't know how they do it, but I trust that they do it correctly.
Can you?
I trust them.
What tools do you think they use?
This is where he avoids...
What is that thing you called, man?
Will it be an optical device?
Yeah.
Yeah. And this optical device gets calibrated and aimed at a particular thing called the apparent horizon.
Is it like, does it measure angles, this device that you're thinking
I
of?
think so.
Or does it look through things and measure distances or whatever, heights above? Yeah? Because that would be using Euclidean geometry, and again, that would be working on the horizontal reference frame, much like the water you've got there. So that wouldn't be a geodesic surveying tool. That would be a planar surveying tool. So, try again. Give us another one. And another tool that a geodetic surveyor would use to measure the curvature of, well, their geodetic surveyors are looking for a curvature in the water level. But you don't agree with that because the water level's horizontal, isn't it? So,
What?
yeah, you've been saying that the water level is a horizontal plane, right?
Mm-hmm.
Well, the geodetic surveyors would be trying to find a curvature within that water level, wouldn't they? So I'd
No.
imagine you'd be,
No, they wouldn't.
but they wouldn't be looking for a curvature in the water level.
They wouldn't care about the water level. They would try to find locations of things relative to other objects, relative to each other, taking into account the Earth's size and gravity. Because this,
sounds like
yeah,
you're
'cause-
off the internet.
no, because as far as I know about geodetic surveying, it's over way larger distances than what normal surveyors do. right?
How do they use gravity to?
Yeah, which gravity?
Yeah, like what's that about?
Mm.
How do geodetic surveyors use gravity to measure the Earth? Please explain.
I would say through the Earth's mass, you could determine its size. I mean, through its gravity, you could determine its mass.
You think Surveyors do that.
Geodetic surveyors, yeah.
What? So they're after the mass of the Earth.
Yep. Yep.
Isn't that a balls in sheds? That, I mean, he wasn't a surveyor, was he?
Who?
Or Henry?
He also wasn't gravity.
Yeah, he was after the mass, wasn't he? The density. That's what he was after with his balls in the shed. I thought.
What, Cavendish?
Yeah. Yeah, right. Was he a surveyor?
No, he wasn't a surveyor.
Okay. Well, but you suggested that that's what geodetic surveyors do.
Yeah, they use graph.
They
help
have
them-
they have tools, much like
help them
Cavendish's
measure
balls
their-
to measure the weight, mass. I don't know. Anyway, so but we're not after that. We're after the shape, aren't we? Isn't that what we're after? Because you said it's horizontal, but then geodetic surveyors measure a curve, do they?
Yeah, they measure. So they're not worried about whether water is level at its surface. They're worried about the shape of the Earth.
Right.
And water is not going to tell you the shape of the Earth.
You can still hold it true that the water level is horizontal, but there's some dude
The water
somewhere.
level is a horizontal plane of reference that
Yeah.
is level at different points, regardless of the shape of the thing it's resting on.
Okay, yeah.
So water surface is not going to tell you the
But
shape of the Earth.
there are some dudes, though. You still hold it true that there are some dudes called geodetic surveyors that measure a curvature in that horizontal plane of reference that you claim. And me as well. I mean, I agree that the water level is a horizontal plane of reference.
Could you say that again?
The water level is a horizontal plane of reference. It does that. Water at rest, when it finds its level, that level will be a horizontal plane of reference. Right? We both agree on that. But you seem to think that there are some people out there that measure a curvature. Because did you ever hear my logical statement from Modus Tollens, if you want to call it that? Like, if the Earth is a spherical object, then the surface of liquid water must curve. Have you heard that as a logical statement? PQ. Right?
Sorry, please say that again.
If the Earth is a spherical object, P, then the surface of liquid water must curve. Q.
If Earth is a spherical object, the surface of liquid water must curve.
Q.
So the surface of oceans
Well,
on water.
but see, that's the logical statement. Then you make it into a modus tollens by denying the antecedent. The consequent. To deny the consequent. So we have to deny the fact that surface of liquid water must curve. Now, you have already agreed with us that the surface of liquid water establishes a horizontal plane of reference. That
At a
is
point,
a
yes.
straight line with
At a
no
point.
curvature.
At a point, yes.
At a point.
And that point can go all the way across because it's a horizontal plane of reference.
Yeah, it's the plane of reference.
Yeah.
It's a
Well,
reference.
2, 3,
plane,
4,
yeah.
5, 6, and 7.
It's a
8,
plane
9,
of
10
reference.
point.
Yeah.
Oh.
Okay, so
Yeah, it's a plane of reference.
they're all horizontal plane of reference, right? The surface
No,
of the water.
you know
So-
what he's doing?
No,
He's
we've
literally-
done it. We've just done it.
No, but he's actually trying to conflate and in his own
But let us finish the modus tollens first, because that is
Won't make any difference.
negating the curvature, Nate. So if there is no curvature in the surface of liquid water, then you can negate the antecedent, can't you? Earth cannot be spherical. Right, Nate? You agree?
I don't agree with anything you just said, man.
You agree that the surface of liquid water is horizontal frame?
At a point, yes. It creates a horizontal plane of reference at a point, and you use that point to level it out with another point.
Yeah, but Nate, you agreed with me that when we were looking at that, the Earth curve between HO and H1,
Mm-hmm.
you agreed with me that to get the water level, we would need to dig a trench between H1 that was 1,160 odd feet from horizon point at the tangent to the curve.
No. I never agreed to get
No,
a level.
no, you
I
did. You
agreed
did.
that when you
You
get to
did.
the horizon point, you are 11,000 feet down. That is the drop in curvature. It is the
Yeah.
water is level at its surface, which is the checkered line. We agreed that
No.
at the horizon point, you would be 11,000 feet down. HO.
1100, 1000. We'd call it 1,100. Just
Yeah.
so it's 1,100 feet.
Might as well be
Yeah,
11,000 though, mightn't it?
Well, it might as
Sorry.
well. Yeah.
Yeah, you would be 1,100 feet below point HO. Yes.
No. Not below point HO. That if we dug, remember we had this conversation that HO and H1 are 41 miles apart, the length
Mhm.
of the longest bit of canal in the UK with no locks between it.
Mhm.
Yeah. To
Mhm.
get that water at a horizontal plane, then the distance we have dug down from point horizon in the I'm looking at the diagram that was put into the text chat, yeah. That point horizon, where the arrow is, at the tangent of your dotted line to the green curve, down to the surface of level of the water, that point would be 1,100 feet.
That
you
is
agree?
where you lose me, man.
You agreed to that earlier.
I think what I agree to isn't what I understand you're saying now.
Well, I'm saying exactly the same now as I said then.
Yeah, you are, and I think I misunderstood you then, because I did say it
But
back to you, and you said what I said was right. So I think that's what caused the confusion. So if I drew a straight line from HO to H1 that cut through all of that gray stuff, so it's underneath the green line, right?
yeah, so far so good.
Okay. And then I stood on that line at where the arrow for the horizon points. So I'm underneath the surface of the earth on that line. I would be 1,100 feet underneath Earth's surface at the horizon point.
It's not only you; it's the level horizontal surface of the canal that is 41 miles long. You're changing it from us talking about the surface level of the water now to us talking about you, and we're not. We're talking about the horizontal surface level of the water.
Okay, so where the horizon point is on the surface of the water of. Okay, okay, yeah. Then even that. Okay, cool. Yeah, that's 1,100 feet below me, but they're still level. Yeah. So that point of there the water surface is 1,100 feet beneath my feet, but it's
No,
still
it's
level
not
with me.
beneath you. It's not beneath your feet. It's how far they have had to dig down through the curve of the earth between each end of the canal. That's the bit you don't seem to understand, Nate.
No, he understands fully.
It's how far they have had to
willful
dig down
refusal.
through the curve of the earth between one end of the canal and the other
Mhm.
to get a level surface The horizontal plane of the level surface of the water. This is according to your model.
Mm. All right, then I'm not understanding what you're saying. Maybe I need to see how they build canals.
See
'cause
that?
I'm
See
not
that dotted
visualizing it in
line?
my head.
See that dotted line?
Mm-hmm.
Right? Like, that is the surface of the water. Like you said, right? That is independent of the shape that's underneath it. Right? Like you've said, that's what the water does. Right? It is. So, you've either got to imagine that when they built the canal, that either end of it, they built the land up to make it look like it's level all the way along. Like that. So them little H arrows must have been built up either side of the canal to make it run level. Or they dug down into the land of the hump at either side of it. In which case, the water level would be relative to the point that they're at, only at the top. Right? You would have to fix your reference frame to say that that's how it works. But that's not how you imagine the water level works, is it?
All right. So I just posted a picture now. That's what I'm talking about. I hope that provides clarity on where I stand.
Right, so is that horizontal plane
At a point, yes.
at that, the one round the dotted line round the outside of that circle there?
At every point on that checkered line, I will have a horizontal plane of reference.
You don't understand what
which
a
is
horizontal
level
you
to
don't
every other
understand
point.
what a horizontal is, do you?
I do.
No, you don't.
Yeah, he's being willfully ignorant. He's deliberately skewing it.
Yep.
Because it's the only way it can fit in his head, even though he knows.
So Nate, right? I've got I'm at the top 12 o'clock on your picture. Yeah, I'm at 12 o'clock. Okay. And you are saying that the dotted line directly on my zenith above my head is horizontal. Okay. Bev is at 3 o'clock on your ball. And you are saying that the checkered line, the dotted line above his head, above his zenith, is a horizontal. Okay. Curios is at 9 o'clock. The same thing applies. You are saying that the checkered line, the dotted line above his head, above his zenith, is a horizontal. Now, the thing about a horizontal line is you can extend it indefinitely. It does not have a beginning and it does not have an end. Right? Now, if we all extend our horizontal lines, what happens?
They will meet at perpendicular angles.
At perpendiculars.
Yeah.
How can horizontal lines... How can that be?
Because you all have your own individual horizontals.
No,
Because you are not on a flat
Bev,
Earth.
that's
We're all
for you.
special.
The Earth isn't flat.
That's
Yeah.
for you, Bev.
Yeah. If I dropped a plum and you dropped a plum, our plums would not be parallel.
That doesn't
That's
work
simple.
geometrically. Like, you're
It's
just
absolute-
making stuff
That's
up.
simple.
You are now.
Yeah, absolutely. This is the double speak,
Yeah.
which has just undermined all your arguments.
Dear, oh
So you guys
dear,
are saying
Nate,
there's
Your
only
pure
one
logical
level in the
fallacy.
whole world.
Yeah, he's
No,
What you're
you
actually
are-
saying
you are
is
making
classic.
shit up.
on your model, there can never be a flat horizontal plane. It doesn't exist. You can't have it. Literally, you draw a circle and you claim that to be a flat horizontal line. That is how your mind works. That's how stupid and how ignorant and how much of a double speaking. You haven't got any argument. It's absolutely horrendous. And you can't even see that.
Yeah.
I feel sorry for you, pal. I really.
All right, man.
I've been telling you about your cognitive dissonance like all this time, mate. That's what we've been trying to get to. It's like you hold two beliefs at the same time. And you can't see that there's a conflict there, but
Conflict,
there's
yeah,
obviously a
major conflict.
massive
Opposite
conflict.
to each other.
Can't I?
What, you can't see that there's a conflict, or you can see that there's a conflict?
I don't see any conflict.
No, that's the good thing about it.
Exactly.
Yeah.
It's a bit. It's same with the Coriolis force. It's the same with all this stuff. You know when their argument is run when they've actually got a totally. Funnily enough, they've actually got tangential arguments against their own position. He's actually got tangential arguments, which means arguments in the opposite of each other. They're literally arguing from a position of tangential arguments. And they can't even see that. That's how bad it is.
Okay, so this is from the constructor site. So this is a civil engineers organization. It's like their home website. So this is for civil engineers. And they say, level surface is a continuous surface parallel to the mean spheroid of the Earth. The line representing this level surface is termed the level line. The level line makes right angles to the vertical line or plumb at any point. It means that at any point on the level line is equidistant from the center of the Earth.
No, it doesn't.
Even
it
though it
means
is a
you
curved
can think
surface,
that.
It is considered a plane surface for smaller area
No,
works.
no, no,
This
no,
is
no.
what
Plane.
that's not
Absolute
what I'm
nonsense.
saying. That is what the constructors
Yeah,
organization
it's a plane
is saying.
surface.
The civil engineering home
Double
website for
speed.
constructors. That's
And
what they're
that's-
saying. Now you guys aren't arguing with me. You're arguing with
I'm
constructors.
not-
No,
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 no, no.
Nobody's arguing
that's
with
what's going
them.
on now.
Read the words that he said.
But that's what they're saying.
It's
They're
double
saying
speak.
it's a plane surface.
That's what they're saying. They're
Yes,
saying even though it's a
yes.
curved surface,
No,
it is
it's
considered a
not
plane
curved.
surface.
No.
They
But that's
never
what they
measured
said.
The curvature.
They're saying that
They've
though.
never
They're saying it's a
measured the curvature.
Then
They've
you
never
need to go and tell them
measured
that.
the curvature. How
You
did
should
they
go tell
measure the
them that.
curvature in the first instance?
You should go ask them. I don't know. I told you I don't know.
Oh yeah,
how they do
here
it.
we go. So now
Curvature.
here you
But
go.
I
It's
trust them.
amazing how all of a sudden
I
you don't know
trust
you're
them.
ignorant of a subject. You
I
know what?
told
Go
you
away
from
and
the
learn
beginning.
how they measured
I
it in the
don't
first
know
place, then come back.
how geodetic surveying
nothing
works. I
to
told you that
measure.
from the start.
Like Nate's already said. And
You guys
like
need to
this
go
guy
and
say,
figure it out for
it's a
yourself.
plane. Where's the curvature to measure? Nate? You already admit it's a horizontal reference, don't you? The water level's horizontal. These guys say it's a plane. You just have to think of it as a curve. That's where it is, Nate. That's how you can hold them two beliefs at the same
Right.
time.
What also you need to take into consideration the double speak that's in that, which you clearly is the fact that on that model there can never, ever, ever, ever be a straight horizontal plane. Can't exist. It can only ever be curved. Why? Whatever degree does not matter, because that's why they say we've got to consider it as this. That's double speak. There is no option for any actual flat level plane on that model, and yet we measure flat level planes. You're literally using tangential argument. You're in opposition.
You guys need to go argue with
I don't need to go and argue with anybody.
the
You're
people
Yeah.
that
And you're full of
say
ignorance.
I trust these guys. I would rather trust
Which bit do you trust?
surveyors than you guys.
Which bit do you
The
trust?
bit where they say it's a curved surface.
Oh, right.
That
Not the
bit.
bit where it's a plane.
So this is what they say. Level surface is a continuous surface parallel to the mean spheroid of the Earth. That means mean spheroid, the mean sphere of the Earth. Sphere.
No.
The Earth is a sphere.
No.
Then they say, even though it is a curved surface, it is considered, right?
Yeah.
It is considered as plane surface
What?
for smaller area works.
What's how
Even
big?
though it
how
is
big's that
curved,
small area?
for smaller area
well, how
works,
big's
we
small
consider it a plane surface.
How big's that small
I
area?
don't know. No, they haven't defined what small is,
Well,
but I would assume like a
listen, Nate,
house.
you said
Like a
before.
house
No,
is
no,
small.
Nate. You said
Yeah.
before the water level is horizontal. Doesn't matter how long it goes. That's what
Guys,
you said.
the surveyors say the Earth has a curved surface. You need to go argue with
and
them.
you trust them.
I trust them.
You
Wholeheartedly.
believe them.
I believe them.
You-
They have
you
given
have
me
a
no
belief.
reason not to believe them.
You
No
have a
quantity
belief
surveyor
in
or
them.
geodetic surveyor has ever lied to me. So I have
But you
no
have-
reason not to trust
You have
them.
no proof from them.
No,
You just
sorry.
Oh, I have
believe
plenty
No,
of
no, no.
proof.
Wait a minute.
I
Can I
just
just go
posted their
back?
proof.
Who's never lied to you? Which type
The
of surveyor?
geodetic and quantity surveyors. have
Oh,
never lied.
geodetic and quantity surveyors. What about the
Yeah.
plane surveyors, or just normal surveyors?
No, I've never met a normal surveyor that told me the Earth is flat.
What about it that levels horizontal?
Well, you've met loads of surveyors, amazing that you know all that. A question for you, right? So you will
Yeah.
agree that what you've got is a religious belief system, and you're happy to have that religious belief system, yeah?
No, it's not a religious belief system because
Yes,
I don't
it
worship.
is. You've
I
just
don't
said it's a
worship
belief.
surveyors.
No, you
I
just
believe them,
said
but it's not religious.
it is.
It's
That's
not.
exactly what it is.
I don't
You've
worship
you,
them.
No, you've
I don't
just,
pray to them.
It's a dogmatic
You don't
belief
need-
system.
It's not about praying.
It's not
Religion isn't
dogmatic.
about praying. It's
It is
about having
dogmatic.
blind belief
I don't believe
without actual
everyone.
evidential proof.
But this
It is a
info,
dogmatic
I
With
believe.
no
belief system.
actual evidential
no
proof, which makes it a religious belief system, sir.
and
not
it's
religious.
If you
taught-
and it's
admit that,
taught
I'll
as a
be
proof,
happy.
which makes it
I'll be happy for you
dogmatic.
to have your religious belief. I'm not a problem with that. But you're asserting it as absolute fact, and it isn't. And you just said you believe, and so do they. It's a religious belief system.
I
That's what
believe
it
them
is.
when I believe that they've studied it and verified it for all of us. Yes,
But they haven't.
it's not a religious
You
belief
believe.
system
So
because
you-
I don't
you've got
pray
a
to them.
belief.
But there is belief involved. I totally agree with
It's
you. I
all
believe them.
belief.
Yeah,
It's
but not
actually
all
make-believe.
belief is religious. No,
It is.
I don't worship them. I don't pray
You
to
don't
them. I
need
don't
to.
call them my
Religion
God.
isn't about worship.
It is.
Religion is based
Religion
on
is
blind
about worship.
belief. And having,
Religion
you've
is
got
based on
belief.
worship.
No, you have belief and faith in them. I know it triggers you an awful lot, but
No.
all you've got is faith and belief in
Religion
them.
is defined
It's
as the
based on
belief
faith and belief, which
worship
makes
of
it a
a
religion.
superhuman controlling
You have
power.
a religious
That is
belief
the definition
and faith
of religion.
in what they tell you. You can keep speaking over me like you keep doing when you finally get to a point. Every time I get to a
I'm
point,
sorry.
you speak
I
over me.
apologize. I'm sorry.
Well,
You've
let
got
him
a
speak.
religious
Stop
belief
apologising.
system. You
and let
have
him
faith
speak.
in them. You believe them, and that's all it's based on. It's not based on anything else. Literally, their own doublespeak undermines their own positions they're trying to claim.
Okay. So religion is defined as the belief and worship of a superhuman controlling power. So what I have is belief, but it's not a religion. I don't worship
Yes,
these
it
guys.
is.
They're not a
Yes, it is.
superpower. No. But if
Yeah.
if you feel it is, it's fine. I don't care.
Okay.
All I know is nothing comes out of the world of flat Earth, but the heliocentric model produces all of these wonders.
Oh, we're
You're
going to
joking.
heliocentrism now. Wow, eh? Oh, dear.
That is a proper belief system. No proof
That
of
is
anything.
religious beliefs, and heliocentrism is actually sun worship. It puts
Sun
the sun at
god,
the centre
isn't
of
it?
everything.
Yeah, Helios is the sun god. So that is a religious belief system.
Yeah.
Okay.
So there you go. That's exactly what you're worshipping, sir.
All right, man. It's cool. If it's a religious belief system, I'm fine with that, man. As long as
it's a
as long as it
dogmatic-
provides
it's a dogma.
models,
It's a
as
dogma
long as it
as well.
provides models.
Well, you see, it
that,
doesn't. You see, it doesn't. It provides
does.
it provides individual
You're not even
models
letting me finish.
that work as standalone models. But you try and combine those standalone models into a combined working model, and guess what? You're just as fucked as the flat Earth.
Nope.
You
It works
you
seamlessly
cannot.
well together.
No,
You
it
cannot.
doesn't.
No, it
Yes,
doesn't.
it does.
No, it
No,
doesn't.
they don't.
You
Yes, it
haven't.
does.
You have not got a complete working model. You haven't
We
got
do.
one.
You do
You
not.
No, you don't.
You do not.
We
You
do.
can. You cannot
Present
even.
it. Bring it forward.
Yeah.
And you
It's
know what?
it's
Your
it's not
rumpus- your
100%
rumpuses and
accurate
all them
if that's
people-
what you
your
mean.
rumpus, your rumpus and all them people will say the same. They will not back you up on that point.
So you do not have a working model. You claim you do, but you don't have one.
We do. It's not 100%, you know. The standard model has its flaws, but it works and we work with it to this very day, and you know, we make inventions and discoveries using it. It works just fine for us. Nothing comes from flat earth.
Again, that's your belief system.
That's cool. I don't care, man. My belief system is what you guys live in, so it's
No,
whatever.
we don't. You actually live on, for want of a
Okay,
better
cool.
term, a flat Earth, but you just don't realise it.
That's fine, man.
You just
I
deny
guess
it.
at the end of the day, reality is subjective. So